Welcome, ladies and gentlemen, to Kate and Megan's presentation of Newton's 3 laws of motion. Thank you for watching, and we hope you enjoy the show.
Let's start with Newton's first law of motion. It states, an object at rest tends to stay at rest, and an object in motion tends to stay in motion, unless acted upon by an unbalanced force.
Let's do a demonstration first. This book will stay at rest on the table unless an unbalanced force, like my hand, pushes it off the table.
This football will stay in motion when I throw it, unless an unbalanced force acts upon it. Gravity, which is an unbalanced force, acted upon the football and took it out of motion.
Another real-world example would be playing golf. When you put the golf ball on the tee, it will stay in the exact same place, meaning it is at a balanced force, unless your golf club, an unbalanced force, hits it.
Moving on to Newton's second law of motion. It states, force equals mass times acceleration. Stronger forces cause faster motion. Heavier objects need more force in order for motion to happen.
Let's do a demonstration of Newton's second law of motion. Here we go. The small black car was able to move with just the slightest bit of force from my finger, but the bigger red car took more force from Megan's finger to move the same speed and the same distance as the small black car.
Another real-world example would be a math problem. Say a volleyball was served with a force of 12 newtons and its mass was 6 grams. How much acceleration did the volleyball have? First, you would plug the force and mass of the volleyball into the equation stated by Newton's second law. Force equals mass times acceleration. So the equation would now be 12 equals 6 times a, acceleration. All you have to do is divide 12 by 6 to get a, and since 12 divided by 6 equals 2, the acceleration of the volleyball would be 2 meters per second squared.
Finally, we have Newton's third law, which states, for every action there is an equal and opposite reaction. The direction of the force of action is opposite the direction of the force of reaction. Let's do a demonstration of Newton's third law of motion. Shall we?
Since the bouncy ball was dropped onto the table, the force of its action was going down. Therefore, its equal and opposite reaction would be to travel up to the exact same spot.
Another real-world example would be a rocket launch. As the rocket pushes on the gases from the engine, which is the action force, the gases push an equal and an opposite amount of force onto the rocket, making the rocket travel up, which is the reaction force.
Thanks for watching. We hope you enjoyed the show.
Bye!